of the past paper questions based on the derivatives topic for IBDP AHL. In part 1, I solved from question number 1 to 9, from now 10 to 20. Question number 10, Fred makes an open metal container. It's an open metal container of a shape in a cuboid. Then length, height is x, width is x, and length is y. The volume is given as 36. So volume is length times width times height equals to 36. So x square y equals to 36. Xy will be equals to 36 upon x. Now A is the area. So what should be the area now? We know that area is, there are on left side and right side, area is going to be x square. Left side and right side, the area is x square. Front and back, the area will be 2xy. And whereas the base is also xy. So area equals to 3xy plus 2x square. That is the reason we found xy. Now I will substitute that xy value, which is 36 upon x plus 2x square. So which is 108 upon x plus 2x square. That's the area. Next, find a prime x. So what am I going to do? I am going to find it out a prime x. So area is 108 x to the power of negative 2 plus 2x square. Its derivative will be minus 108 x to the power of negative 1 plus 4x, which is going to be minus 108 upon x plus 4x. That's going to be the a prime x. Next, given that the out of surface area is minimum, find the height of the container. So area is going to be minimum. So for area going to be minimum, a prime x should be equals to 0. So minus 108 upon x square plus 4x should be equals to 0. So 4x equals to 108 upon x square. 4x cube equals to 108. X cube equals to 27. So x equals to 3. If x equals to 3, we know that xy equals to, what is the height? Height is the x only. So therefore height equals to 3. Height equals to 3 centimeters or 3 meters. Next, Fred paints the outside of the container. A tin of paint costs a surface area of 10 meters square and cost $20. Find the total cost of the tin needed to paint the container. Now, so minimum surface area, we know x is 3, therefore we are going to find it out. The minimum surface area is going to be 108 upon x plus 2 times of x square, which is going to be, this is 36 plus 9, 18, so which is going to be 54 meters square. So it is costing, for 10 meters square, we are going to get it out 1 can. So total cost will be, so how many cans it will be? Number of cans. Cans will be 54 divided by 10, which is 5.4. So 5.4 means 6 tins. But each tin is $20. So 6 times $20. So therefore it's going to be $120. That's going to be the answer. Question number 11. Write down the equation of the horizontal asymptote. Horizontal asymptote will be always this, y equals to 2. Find f prime x. F prime x will become, this can be written as x minus 1 whole to the power of negative 1 plus 2. So what will be f prime x will become minus x minus 1 whole to the power of negative 2 plus 0, which is minus negative 1 x minus 1 whole square. Given that g of x equals to a e power minus x plus b, the graph of f and g have the same horizontal asymptote. Find the value of b. So y should be equals to 2 is the horizontal asymptote. So therefore b equals to 2. Given that g prime x 1 equals to minus e, find the value of a. So what is g prime x? G prime x equals to minus a e power minus x. So g prime 1 will be equals to negative e minus a e power minus 1 equals to negative e minus a upon e equals to negative e, a equals to e square. There is a value of x for x lies between 1 to 4 for which the graphs f and g have the same gradient. Find the gradient. So what is this? F prime x equals to g prime x. F prime x is minus x minus 1, 1 divided by x minus 1 whole square equals to minus a e power minus x. Now, if you draw the graph, you should be able to get that the point of intersection of these two should be 2 comma negative 1. So the gradient is going to be nothing but what? Negative 1 is going to be the gradient. That's going to be the answer. Next, question number 12. Let y equal to f of x. X lies between 0 minus 0.5 to 6.5. The following diagram shows the f prime x, the derivative. The graph of f prime has a local minimum value at x equals to 2 and x equals to 4. It crosses the x-axis at maximum at x equals to 2 and minimum at x equals to 4 and crosses x-axis at 5, 0. Explain why the graph has a local minimum at x equals to 5. So first condition is f prime 5 equals to 0. Then what is the thing is its derivative is from negative to positive. So there is a change. The derivative was negative, it becomes 0, then it becomes positive. So it is going to be a minimum point. So you have to write it out over there as f prime changes. Write the reason. F sign changes sign from negative to positive at x equals to 5. So therefore it is minimum. Find the set of values of x for which the graph is concave down. So concave down means f prime should be a decreasing function. Implies f double prime should be less than 0. We can clearly see that x lies between 2 to 4. Next, 12c. The following graph shows the shaded regions A, B, C. The regions are enclosed by the graph f in f prime, x-axis and y-axis. The area of the region is 12. The area of the region B is 6.75 and C is 6.75. F of 0 is 14. Find f of 6. So I want to find it out from area. Integration means area under the graph. 0 to 6 f prime x dx will become f of 6 minus f of 0. F of 6 minus f of 0. Then what am I going to do that? I have to use the integration to find the area. So integral 0 to 6 f prime x dx will be negative 12 negative 6.75 plus 6.75, or basically it's going to be the area of A plus area of B plus area of C. So negative 6.75 positive 6.75 gets cancels. So we will be getting it out. Integral of 0 to 6 f prime x will be equals to nothing but what? Negative 12. So we got that area as negative 12. But we know that f prime x is nothing but what? F of 6 minus f of 0. F of 0 is already given as 14. So f of 6 minus 14 equals to negative 12. So f of 6 equals to 2. I could able to find f of 6 equals to 2. See carefully, pause the video and see the logic what has been done. You will be able to understand. Question number 12D. The following diagram shows the shaded regions A, B, C. The regions are enclosed by the graphs. The area of the region is 12, area of the region B and C. G of x is equal to f of x whole square. F prime 6 equals to 16. Find the equation of the tangent to the graph at G where x equals to 6. So first of all, I am going to find it out, g of 6. I'm going to find g of 6, which is nothing but what? F of 6 whole square. What is f of 6? F of 6 is 2. It is given that f of 6 is 2, so it is going to be 2 square, which is going to be nothing but how much? 4. Now we have to find it out. What am I supposed to find it out? G prime of g of x. G prime x. How can I find g prime x? 2 f of x, first power rule, then again f prime x. So I am looking for what it says, equation of the tangent to the graph g. So I should be able to find out g prime 6. So what will be g prime 6? Will be 2 f of 6 times f prime of 6. So 2 f of 6 we have just proved it as 2, f prime 6 is given it as 16. So it is going to be 64. So what is going to be the gradient? Gradient is going to be 64. So in order to know the equation of a tangent, we need to know point and the slope. Slope we came to know it as 64. Now we need to know only the point. So the point is nothing but how much? We know we are supposed to find it at x equals to 6. And what is the value of y? So 6 comma y value. When x equals to 6, what is g of 6? So g of 6 already we found it as 4. So therefore 6 comma 4. So we know the point and we know the slope. So what will be the equation? Y minus y1 equals to m times x minus x1. So it becomes y equals to 64x minus 380. This is going to be the answer. So first find g of 6, then find g prime x by using power rule and chain rule, then find g prime of 6, then that's going to be the slope, then find the point, then use the formula y minus y1 equals to m times x minus x1. Now question number 13, a function has a derivative f prime x equals to 3x squared minus 2kx minus 9. Find f double prime x. So what is f double prime x? 6x minus 2k. The graph f has a point of inflection at x equals to 1. Show that k equals to 3. So what does it mean? F double prime of x should be equals to 0. So 6 times of 1 minus 2k should be equals to 0. 6 minus 2k equals to 0. 2k equals to 6. K equals to 3. Find f prime of minus 2. So what is f prime of minus 2? 3 times of negative 2 whole square minus 6 times of negative 2 minus 9, which is going to be 15. The equation of the tangent to the curve at f at minus 2 comma 1, giving your answer in this form. So we know the gradient is going to be 15. So it will be in the form of y equals to 15x plus b. Now it is at minus 2 comma 1. So plug in that 1 equals to 15 times negative 2 plus b. So you will be getting it out b value equals to 31. So what is going to be the equation? Y equals to 15x plus 31. Given that f prime of minus 1 equals to 0, explain why the graph has a local maximum at x equals to negative 1. So I'm going to find the second derivative. What is the second derivative? We know that first derivative is 3x square minus 2kx minus 9. The second derivative is 6x minus 2k. 6x minus 2k. K value is nothing but what? 3. So which is 6x minus 6. Now at x equals to minus 1, the second derivative is 6 times of negative 1, negative 6, which is negative value. So therefore, if the second derivative is negative, means it is going to be a maximum value. Next question number 14. Consider the function f. X lies between 0 to 10. The diagram shows the graph f prime, the derivative of f. The graph f prime passes through 2 comma minus 2, 5 comma 1 and have x-intercepts at 0, 4 and 6. The graph of f has a local maximum point at P. State the value of P and justify your answer. So this is going to be local maximum point at P. So maximum point means positive, 0 and negative. The derivative becomes positive, it is 0 and it is negative. So that's going to be the value of 6. So that is the reason why P value is 6. At x equals to 6, gradient changes sign. Changes sign from positive to negative. Therefore, it is going to be maximum. Write down f prime of 2. It is negative 2. Then let g of x equals to ln f of x. F of 2 equals to 3. Find g prime 2. So ln f of x, g prime x will become 1 upon f of x times f prime 2, f prime x. So at g prime 2 will become 1 upon f of 2 times f prime of 2. Now f of 2 is 3 and f prime 2 was negative 2. So answer is going to be minus 0.667. Verify that ln 3 plus integral 2 to a g prime x dx equals to g of a. So ln 3 plus g prime x derivative integral will be g of x from 2 to a is going to be nothing but what? G of a. So ln 3 plus upper limit minus lower limit minus g of a minus g of 2. So ln 3 plus g of a, g of 2 is nothing but what? Ln f of 2. F of 2 is again 3. So ln 3 plus g of a minus ln 3. Ln 3 gets cancels. It's going to be g of a. The following diagram shows the graph g prime. Find the derivative of g. The shaded regions g prime, the derivative of g. The shaded region A is enclosed in the curve and x-axis and the line x equals to 2 and has an area 0.66. The shaded region has an area 0.21. Find g of b, 5. So this is 2 and this is 5. So from 2 to 5, I'm going to find g prime x dx. So it's going to be g of 5 minus g of 2. G of 5 minus g of 2. So what is g of 5? G of 5 is ln 3 plus 2 to 5 g prime of x dx, which is ln 3 plus g of 5 minus g of 2. So we have cleared a formula over here. Ln g of a will be equals to, if at all from 2 to a I am doing it out, it will be directly g of a. That formula I am going to use it out. So it's going to be directly g of 5. Ln 3 plus g of 5 based upon the formula. But according to the, what is the area? The area given in the question is 0.66 and 0.21. 0.66 is negative and 0.21 is the positive area. So I have to find it out over here. From 2 to 5, g prime will be, and I clearly do that once again over there. So I have used the formula from here. We carry forward the formula ln 3 plus 2 to a g prime x. Let me write it out over here. Ln 3 plus 2 to a g prime x dx will be equals to g of a. That is the standard we have derived it out earlier. So now I erase this one once again and write it out neatly. So what am I going to find? I am going to find, putting a equals to 5 in the formula of g of a. So integral of 2 to 5 g prime x dx. 2 to 5 g prime x dx. Now If at all I'm going to add ln 3 to that, it becomes into this formula and I can use it as g of 5. So I have to get the value of this one now. So, g of 5 will be equals to ln 3 plus 2 to 5 g prime x dx. So which is ln 3 plus 0.66 is in negative area, so minus 0.66, whereas 0.21 is in the positive area, plus 0.21. So it's going to be ln 3 minus 0.45. This is the easiest way of doing the question. The following diagram shows the graph of the function f, the local minimum point at a. The derivative of f is given by this one. Find the x coordinate of a. X coordinate of a means first derivative should be equals to 0. Minus 3 should be equals to 0. So it becomes 3x plus 1 times x minus 3 should be equals to 0. So x equals to 3. Because x is greater than 0, x equals to minus 1 upon 3 is rejected. So only x equals to 3. The y-intercept of the graph is at 0, 6. Find the expression of f of x. So f of x equals to integral of f prime x dx. So that will become x cube minus 4x square minus 3x plus c. Now the y-intercept is at 0, 6. So plug in that one. 6 equals to 0 minus 0 minus 0 plus c. So c equals to 6. So therefore f of x will be x cube minus 4x square minus 3x plus 6. The following diagram shows the part of the graph. The graph has a local maximum at a where x equals to minus 2 and local minimum at b where x equals to 6. On the following axis, sketch the graph. So I am sketching the graph over there. Minus 2 and 6, because this is positive to negative. Positive to negative, so therefore it's going to become minimum. This is negative to positive, so therefore this becomes maximum. Write down in order the least values of f of 0, f prime 6, f double prime minus 2. So what is f double prime minus 2? So we know that from least to the greatest. So therefore I have f prime of 6 and f double prime of minus 2 and f of 0. F of 0 value is 6. F of 0 value is 6. This value is 6. F prime of 6. F prime of 6 is 0. Then f double prime of minus 2. Now f double prime of minus 2. So therefore again f double prime of minus 2 is also, because f prime is 0. So therefore it is a maximum point. Now f double prime is also going to be nothing but what? 0 itself only. So therefore what is the order? F double prime minus 2, then f prime 6 and f of 0. That's going to be the answer. Consider the graph of the semicircle given by f of x equals to 6x minus x square. PQRS is drawn on the upper vertices. R and S are on the graph of f. PQ is on x-axis. Then let OP equals to x. Find PQ, giving your answer in terms of x. Hence write down the expression for the area of the triangle. Now I have to find it out, PQ. So we know that this total distance is 6. If this is q to 6, if this part is x, so this part also going to be x. So what is going to be PQ? PQ is going to be 6 minus 2x. Now area is going to be length times the width, which is square root of He has given it as 6x minus x square, because consider the graph of a semicircle. So this is y value. Y value is 6x minus x square under root. So area equals to length times width. So length is 6 minus 2x and the width is square root of 6x minus x square. Find the rate change of area when x equals to 2. So dA by dx, du dot by GDC, and find it out at x equals to 2. You should be getting it out negative 4.95. Find the area is decreasing between A to B. Find the values of A to B. So you can see from the GDC, the values of A to B should be 0.87923. Let f of x is x greater than 0, 6x upon x plus 1. Find f prime x. Use the quotient rule. So f prime x should be equals to x plus 1 whole square, x plus 1 times 6 minus 6x times 1. So which is 6 upon x plus 1 whole square. G of x equal to ln, show that g prime x. So g prime x equals to ln derivative is 1 upon 6x upon x plus 1 times derivative of 6x upon x plus 1. Then just now this is x plus 1 upon 6x. Just now we have found it out, its derivative is going to be nothing but what? 6 upon x plus 1 whole square. Now 1 6 and 6 gets cancels, x plus 1 gets cancels. So what should be the answer? 1 upon x times x plus 1. 18c, h of x equal to 1 upon x times x plus 1. The area enclosed by the graph of h, x-axis, and the lines x equal to 1 upon 5, x equal to k is ln 4. Find the value of k. So integral 1 upon 5 to k h of x is, we are supposed to find it out, h of x dx. Now we have to find that particular value. Now h of x is nothing but how much? 1 upon x times x plus 1 dx, from 1 upon 5 to 4. This is equals to ln k. So I am going to find it out the integral of this one. 1 upon x times x plus 1. 1 upon x times x plus 1, just now we have done it at. It is nothing but what? This is g prime x. G prime x integral is going to be, so this is our g prime x. What is g prime x integral will become? G of x, from 1 upon 5 to 4. What is g of x? G of x is ln 6x upon x plus 1, from 1 upon 5 to 4. So plug in that one, 5 to 4 not, it is k. So it was not 4, it was k. So I make the correction over there, it is k. So it becomes ln 6k upon k plus 1 minus ln 6 times 1 upon 5 upon 1 upon 5 plus 1 should be equals to ln 4. So ln 6k upon k plus 1 minus ln 1 equals to ln 4. So ln 1 is 0. So what do I get it out? Ln 6k upon k plus 1 equals to ln 4. Ln gets cancels. 6k upon k plus 1 equals to 4. 6k equals to 4k plus 4. So 2k equals to 4. So k equals to 2. Question number 19. Find f prime x. So cos derivative is minus sine e power x. E power x derivative is e power x. On the grid below, sketch the graph of f prime x. So from GDC, you should be able to get it out something approximately like this. And go up to between 4 to 5 and come down in this way.